Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullah. Today we have to discuss magnification by mirrors. Today's topic. It is magnification by mirrors. Magnification by mirrors. What does it mean? What is the topic about? Remember, a mirror can enlarge an image. It can diminish an image, or the size of image will be equal to the size of object. It can happen. We have seen cases of reflection by a concave mirror. We have seen a case of reflection by a convex mirror. In all these cases, we have observed that the size of image can differ from the size of object. At times, the size of image is smaller than the size of object. At times, it is bigger than the object, and at times, it is equal to the size of the object. How bigger is the size of image than object? Or how smaller is the size of image than object? That is discussed in this topic, magnification. It says ratio of height of image and height of object. Magnification, it means ratio of height of image and height of object. That ratio will tell you, is the image bigger than the object or smaller than the object? How? If the answer is more than 1, if it is greater than 1, it means image is bigger than the object. If the answer is less than 1, it means object is bigger than image. And if it is equal to 1, that means size of object is equal to size of image. They both have same size. So we represent magnification by small m. We represent height of image by h2 and height of object by h1. This is how we can calculate it, by taking the ratio of height of image and height of object. Remember, if m is greater than 1, it means image is bigger than object. Okay? If the value of m is less than 1, it means image is smaller than object. And if m is equal to 1, it means image size is equal to object size. By taking the ratio of height of image and height of object, we will come to know, is image bigger than the object or smaller than the object or equal to the size of the object. Okay, let me represent it by equation 1. That it is equation 1. We can also calculate the value of m. Value of m can also be calculated by taking the negative ratio of image distance and object distance. Okay, negative ratio of image distance and object distance. If we take the negative ratio of image distance and object distance, we can calculate the value of m. It means m can also be calculated by taking negative ratio of image distance and object distance. This is equation 2. We can also calculate the value of m by taking the negative ratio of image distance and object distance. This can be done. by combining these two equations from first and second. I write it here. From equation first and second. From equation first and second, we get H2 upon H1 is equal to minus V upon U. This formula, it helps us to calculate image distance if these three parameters are given. It helps us to calculate the value of U if these three parameters are given. It also helps us to calculate the value of H2 if H1, V and U are given. It helps us to calculate H1 if H2, U and V are given. In simple words, we can calculate any of the variable if the value of three variables are given. The fourth one can be calculated. अब मैं एक numerical लिखता हूँ and we will calculate the value of one of the variable. Let me write down a numerical. The question goes like this. An object is placed in front of a concave mirror at a distance of 10 centimeter. At a distance of 10 centimeter. Full stop. The height of object and image are 5 centimeter and 10 centimeter respectively. Calculate the image distance. This is numerical which we are supposed to solve. What is the numerical? An object is placed in front of a concave mirror at a distance of 10 centimeter. Object distance is 10 centimeter. So let me solve it now. U equals to 10 centimeter. Why minus? ये minus मैंने क्यों लिखा? Because sign convention of mirrors that says when you measure a distance in opposite direction of incident ray, it is taken as negative. Object is always placed in front of mirror and the object distance is always measured in opposite direction of incident ray. So it is taken as negative because sign convention says it. Next, the height of the object is 5 centimeter. H1 is 5 centimeter. Why plus, why not minus? हम हमेशा ऑब्जेक्ट को रखते हैं इरेक्ट पोजीशन में. उल्टा तो नहीं रखते ना, इरेक्ट पोजीशन में रखते हैं. Erect position is always taken as positive. Okay, height of image is 10 centimeter. H2 equals to minus 10 centimeter. Why? Because image बनती है कॉन्केव में 5 केसेस में इमेज बनती है इन्वर्टेड, उल्टी बनती है. एक ही केस है जिसमें इरेक्ट इमेज बनती है, वो एक्सेप्शनल केस है. उसमें इमेज बनती है बिहाइंड मिरर. इट इज नॉट दैट केस. ये वो वाला केस नहीं. सो इमेज का मैंने नेगेटिव इसलिए लिया बिकॉज इट इज इनवर्टेड. इनवर्टेड पोजीशन को हम नेगेटिव लेते हैं. एंड यू हैव बीन आस्क्ड टू कैलकुलेट द वैल्यू ऑफ v. Okay, using the same formula, we know H2 upon H1 equals to minus V upon U. Now give the respective values. H2 that is minus 10 centimeter. H1 that is 5 centimeter. Minus V we need to calculate. U is minus 10 centimeter. ठीक है, अब यहां लिखिए. Look here. Centimeter and centimeter cancel. 5 ones are 5 twos are. So it is minus 2 now. Minus 2 equals to minus minus plus. Minus minus plus. It is V by 10 centimeter. Okay. Now transpose 10. It is minus 2 into 10 centimeter equals to V. 2 tens are 20, minus 20 centimeter equals to, this is the value of V. So image is formed 20 centimeter away from the mirror. Okay, miles means the image is formed in front of mirror, not behind mirror. In front of mirror जो भी distance बनती है वो हमें measure करनी पड़ती है in opposite direction of incident ray, वो हम negative लेते हैं. So image is formed 20 centimeters. Image is formed 20 centimeter away, 20 centimeter away from mirror, but in opposite direction of incident ray. This is how we solved a numerical using magnification. ठीक है. Now let us discuss the next topic. छोटा सा टॉपिक है वो भी डिस्कस करते हैं. उसके साथ ये रिफ्लेक्शन का पोर्शन हमारा खत्म हो जाएगा. Now the topic is mirror formula. Mirror formula. एक formula है which relates object distance, image distance and focal length of a curved mirror. It gives a relationship between object distance, image distance and focal length. Gives what? Gives relationship. Gives relationship between object distance, that is u, comma, image distance, that is v, and focal length, that is f, of a curved mirror. Mirror formula, it gives us a relationship between object distance, image distance and focal length of a curved mirror. Object distance means the distance between the mirror and the object. Image distance, the distance between the mirror and the image. Focal length, you know, that is the distance between focus and pole of the mirror. What does this relation say? It says sum of reciprocal of object distance and image distance is always equal to reciprocal of focal length. Mirror formula, it says sum of reciprocal of object distance and image distance is always equal to the reciprocal of focal length. That means 1 upon v plus 1 upon u is always equal to 1 upon f. This is we call mirror formula. It says the sum of reciprocal of object distance and image distance is always equal to the reciprocal of focal length. Knowing the value of two variables, it is easy for us to calculate the value of third variable. If we know object distance and image distance of a curved mirror, we can calculate focal length of that curved mirror. Or if we know the focal length and object distance of a curved mirror, we can calculate the value of image distance of that particular case. We can calculate that. This is called a mirror formula. Let me write down a numerical and try to solve that using this mirror formula. I write down the numerical. But remember, 1 upon v when added to 1 upon u is always equal to 1 upon f. You remember, this is called mirror formula. I'll solve a numerical now. Let the question is this. An object is placed in front of a convex mirror of focal length 5 centimeter. The image is formed at a distance of 2 centimeter. Find the object distance. Okay, an object is placed in front of a convex mirror of focal length 5 centimeter. The image is formed at a distance of 2 centimeter. Find the object distance. So what is given there? F is given 5 centimeter. Why have I taken the value of 5 as positive value? I have taken the value of as positive. Why? Because it is a convex mirror. The focal length of a convex mirror is always taken positive. So that's the 5. Then V is given, it is 2 centimeter. Again I have taken it positive. Why? Because in convex mirror the image is formed behind the mirror. And when we have to measure the distance between image and mirror, we have to go in the same direction of incident ray. The direction in which incident ray goes, we have to go in the same direction. When we measure a distance in the same direction in which incident ray goes, that direction or that distance is taken as positive. So it is taken as positive. We have to calculate the value of U. We know 1 upon V plus 1 upon U equals to 1 upon F. It is mirror formula. Give the respective values. It is 1 upon 2 centimeter plus 1 upon U equals to 1 upon 5 centimeter. Shall Now I will transpose this 1 upon 2 to the right. It will be 1 upon U equals to 1 upon 5 centimeter minus 1 upon 2 centimeter. Look at it. So it will be 1 upon U equals to 5 2s are 10 centimeter, 2 1s are 2 centimeter, minus 5 1s are 5 centimeter. Clear? It will be centimeter square. So it is 1 upon U equals 2 minus 5 minus 3 centimeter by 10 centimeter square. Square and centimeter cancel. Surely U will be equal to minus 10 upon 3 centimeter. So we calculate the value of U. We have placed U at a distance of 10 upon 3 centimeter. This is how we can use a mirror formula to calculate the value of any of the 3 variables. But the value of 2 variables should be there. ये इसके साथ ही हमारा रिफ्लेक्शन वाला पोर्शन खत्म हो गया और अब हमें आगे इंशाल्लाह रिफ्रैक्शन पढ़नी है. It is enough for today. Stay blessed. Fi amanillah. Assalamu alaikum.